Hi, and welcome to the first of two videos for section 4.4 for Math 126. In section 4.4, we are going to look at what's known as the laws of logs. Now, I know I keep saying, this is a very important section. Well, I'm going to say it again. This is a very important section, and this is a very important video. Not just for this class, but again, if you're going to be going on to a calculus class, whether it's here at UNLV, if it's at a different university, the laws of logs are going to be used a lot. So you're going to have these different functions. I mentioned at the end of video 4.3, the video for that section, how you use natural logs. So you need to be able to apply these law of logs in order to simplify things for you to actually allow you to do the various operations you'll need to do in calculus. So the law of logs are as follows. First, we need to state a few things. We're going to let A be a positive number. And A is not 1. And we're going to let A, capital B, capital C be any real number. But capital A is greater than 0 and capital B is greater than 0. So now that we have that groundwork laid, we get the following laws. And with these laws, they can go either way, left to right or right to left. You can either break things apart or you can combine things. Number 1 says that if I have log base A of some A times some other value B, this is the same as log base A of A plus log base A of my capital B. So again, if I have the addition of two logs, as long as the bases are the same, I can combine it by just multiplying A and B. In addition, number 2, if I have log base A of A divided by B, this is log base A of A minus log base A of B. So again, if I have a fraction, maybe it's easier to separate them and then simplify. Or if I have a subtraction of two logs, as long as the bases are the same, I can combine them and it's just the fraction of A over B. And then lastly, our third law is that if I have log of A, base A, of A to the C power, this is the same as if I bring C out to the front and then leave everything else the same. Log base A of A. So these are our three laws. If you're in my class, you get a cheat sheet, you better have those on there. You're going to have these log problems on your exam. You're going to have it on the final exam. So you need to know these laws. And more importantly, you need to know how to apply them. And we're going to look at some examples here how to do this. So let's do that. Let's look at some examples. First off, I want to simplify. And the first one I'm going to simplify is log base 4 of 2 plus log base 4 of 32. So, it's the addition, which means I'm using rule number 1. So I can actually simplify this, we'll simplify it, to log base 4 of 2 times 32, which is log base 4 of 64. Now remember, in video 4.3, I told you that when you're simplifying logs, you may get to a point and you're like, now what do? I guess I got as far as I can go. And I told you guys that holy grail of the logs, right? Which is what? Can I simplify this? Will this simplify to another value? And it means what? Let's call this x. This thing simplifies into x. So that means what? That means 4 to the x power has to equal 64. Well, 4 to what power equals 64? Well, that's when x is equal to 3. So this entire piece, log base 4 of 64, really simplifies into 3. So number 1, this guy is equal to just the value 3. All right, let's look at another example. I'm going to erase this so we can keep these laws here and keep referencing back. So if you need to follow through, go ahead and hit pause. For number 2, I want to simplify log base 2 of 80 minus log base 2 of 5. So now I have a subtraction. So that means I'm using law number 2, which means I can convert this to a fraction. So this is the same as saying log base 2 of 80 divided by 5. So that's log base 2. 80 divided by 5 is what? That would be 16? Yep. So now 2 to what power is equal to 16? Well, that's to the 4th. 2 to the 4th is 16. So this whole thing is really just equal or equivalent to 4. Last example. So again, if you need to follow through or go back through it, go ahead and hit pause. Otherwise, example 3 is as follows. I want to know what's negative 1/3 log of 8. So, this one looks like what? This looks like number 3, but now we're going from right to left. Remember I said it doesn't have to necessarily be, well, I guess the other ones we did as well. Sometimes you can split them up the other way. But on this one, we're starting with number 3. So this thing is really the same as saying log. There's nothing written there, so that's what? That's base 10. But this is 8, and this essentially becomes the exponent. So 8 to the minus 1/3 power. So if I don't want negative exponents, this is log of 1 over 8 to the 1/3, which is what? The cube root of 8? So the cube root of 8 is what? It's 2. So this says log of 1/2. Now, this is going to be a calculator problem. Obviously, if this is on an exam, that's as far as you can go. If it's in your homework, it might say, listed out the 3 decimals or something. So on your calculator, if you do log, it's already set to base 10 if you're using just the button that says log. Otherwise, you'd have to use the one where you could change the base. But this one is base of 10. So log of 1/2, if you hit it on your calculator, you should get something approximately negative 0.301. Which makes sense, right? Because remember what the log graph looks like. It looks like this, where it's crossing through at 1. So any value between 0 and 1 is going to be a negative value. Any value bigger than 1 is going to be a positive value. So since I'm taking log of 1/2, that's somewhere in here, and my value should be a negative number. So we can feel pretty good that that's probably the right calculation. So I'm changing on the fly here, looking at my notes. I know I said there was 2 videos. There's actually going to be 3. This next section, I want to break it out into a different video. I want to keep the law of logs and how to apply them in its own video. So come on back, we'll do video 2, and then we'll end with video 3.